Okay, hello everybody. My name is Luca Mugnaini. I'm a software engineer in Rakuten. We have several applications in Rakuten written in at home in production. So I'm mostly coding with purely functional language in the last 5 or 6 years. So today we will talk about handling errors and trains. So let's start with the simple code example. So we have some data as a string in a JSON format, and we are parsing it. And then after we extract the user object and we print somewhere, right? So let's see how this behaves in different scenarios. So the first one, it's all good. We print a hi John. The second case, maybe the backend, the API decide to change the format. So instead name, now we have n. So we are printing hi undefined on the screen. So this is quite a common case. I'm sure all of us have seen this sometime. The third case, it's we get a broken JSON. Maybe there was some network problem, okay? So in this case also, we actually crashed the entire application. So handling errors require some discipline. How can we fix this? So one way, we can ask our discipline developer to fix this code. So we ask him, and he will add all those lines in blue. Okay, let's see how it works now. So first case is still good. Second case is also good. So now we are getting an error that we can handle it. Maybe we don't put an overlay on the big football match on live TV. And then we have the third case is also good. We are getting an error, okay? So we can handle that. We can give a good experience to the user. So the question is, can we replicate the discipline of this developer using an assistant in the form of a static type system compiler? So before going ahead with this question, let me introduce a metaphor. Probably you already know about this one. So the idea is to associate a function with a piece of railway. Okay? So there is a data coming in, and then it gets transformed, and then the data goes out. So when we build our application, we are basically composing functions. So we are connecting piece of railway together, and of course the piece of railway, they have to match each other, okay? So this is our application. Now, what is throwing an exception? What it looks like? It may look like this, okay? We are derailing from our flow, okay? And then we hope that someone will take care of the error down the line. So we can compose this one. So this is our application now. But what happens is, if we don't catch the error or we catch too late, then a crash can happen. Okay? So let's introduce a result type. So a result type is a type that can hold an OK value or an error value. Sometimes also call it an either type, where the two options are left and right. So basically, we are changing our railway from this shape to this shape. We are going ahead instead of derailing completely. So let's see, we need to compose those functions. Can we compose those now? Well, it's a problem, right? They are not connecting anymore. So to connect those, one way is to transform them. So if we apply this transformation, now it's possible to connect them. Okay, so our application now is back on track, and every time somewhere in our code we can fail, we just move from the green path to the red path. Okay, so let's go back to the initial question. Can we now use an assistant in the form of a static type system compiler? So let's see how we can do this with the Elm language. So the Elm language is statically typed and also has a compiler. And by default, the entire language uses the result type, okay? So the analog of JSON.parse in Elm will return a result type. If we try to use the return value, the compiler will give us this error. It says, you cannot use user because this is a result type. It's a type mismatch. Okay, we can fix it. We can extract the user using pattern matching. But the compiler is still unhappy. The compiler says, oh, you're missing one possibility. Okay, the error case is not here. Fine, let's add the error case. So now we cover all the cases. The compiler is happy, and we achieve the same result. But we don't need to be disciplined. We just need to follow the compiler errors. Now, can we do the same with TypeScript? So first of all, in TypeScript, there is no result type. We need to define it. There are many ways of doing it. This is one possibility. I show here also a couple of definitions. This is how it's defined in Elm. But in Elm, we don't need to define because it's already built in the language. This is how you can define in Kotlin. I show this one because we are actually introducing Kotlin as well in our repository. So this is the code. Let's analyze it. So first of all, again, we define the result type. Second, we need to wrap JSON parse because this is a function that can fail. We need to wrap in a code is a try-catch block, and also we have some other if condition to catch some problem if it's JSON is undefined and so on. And we return a result type. And then finally, with a switch block, we check if it's okay or if it's an error. And we also add the exhaustive check at the bottom to make sure that we cover all the cases. So let's see if we get the same errors. So the first error is there. If we try to use the value directory, we get this problem because it's a type mismatch. The second error is also there. If we forget to consider the error case, we get this one. So we achieve parity. Basically, it's the same experience on both cases. Okay, this is good, but do we need to rewrite all our function to use the result type? Well, a simple answer is no, basically, but only the function that failed, as we just did. Let me show a quick example here. So we have those two functions. One is multiply by, the other is divide by. So the first function is always, is never fail, but the second function can fail if a is equal to 0, okay? So let's rewrite the second function like this. So now we return a result type, right? We check if it's 0 and so on. So those two functions, they are the same of those two pieces of railway. So the one that never fails is just a straight line, right? The one that can fail is like this. So we need to have those transformations. So those are very common transformations. So all languages that support the result type or library, they have those. In Elm, they're called map and then. There's an implementation, it's very simple. In JavaScript, this could be the implementation. Basically, if it's an error, you just go through. If it's an okay value, you just give to the callback. Okay? So let's try to do this simple calculation now. Those are 5 operations. So let's use those functions and those helpers, and this is what we get. Okay? This is not so nice. Let's try to format a bit differently. Okay, so here now we start seeing some pattern, but maybe we should improve a bit more. So one way to simplify this further is to do some partial application. So we take our function and we transform it like this. So basically, if we call it with the less argument that it requires, it will return a new function that is waiting for the rest of the argument. So doing this transformation, we get this version that is this cleaner, okay? That I also reported here. So unfortunately, there are still a lot of parentheses, looks a bit like a Lisp. And I also would like the flow to go from the top to bottom, not from the bottom to top. See, 9.3.10 is 9.3.10, so it would be nice to be the opposite. But this is what I guess we can achieve with vanilla JavaScript. We cannot go further. So to go further, there are a couple of very nice proposals now in the JavaScript community. One is the pipe operator for JavaScript, and the other is a partial application for JavaScript. If those two get accepted, when they get accepted, then we could write something like this. So now we could get rid of all parentheses, and the flow is in the right direction. It's interesting to see how the syntax allow us to introduce this concept like the result type from functional programming in a much easier way. So somehow the syntax is the paradigm. So, of course, to move forward, it would be a good idea to have a look at the library that implemented this idea of the result type. Here I put the most popular in TypeScript and Kotlin, and the URL is built in the language. So, to recap, the result type is a type holding an OK value and an error value, and is a way to manage errors using the type system without throwing exception, possibly improving both the developer experience and the user experience. That's all from me. Thank you.
Thank you.